Okay, we started the recording. Let's put up our lecture here. See if we have. Sorry. Okay. Okay. So this is. Um, okay. Here's presentation mode. Okay, so previously in the last lecture, what we did, we presented the architecture and the details of the convolution neural network, and then we presented a simple example here, okay, of detecting the letter O. Okay, and we have an output that indicated it's a letter O, and and a letter X, and we have output indicate that the input image is a letter X, and then tested our the smartness of this new convolution neural network by showing it a shifted image of a shifted image, and it recognize it is a shifted image of X by given this output of X has higher value than the output of O. Now, these are simple ones, so let's go for really more interesting example. In this example, what we will show is that we would want to recognize these signs. We have a sign for horizontal line, and a sign for vertical line, a slope, a negative slope, and a positive slope of 45 degrees, obviously, and a plus sign, and a multiply sign, and a diamond sign, and a 3-point star, and an arrow, and a yacht. And so how many of those? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 signs. That's right. And I want to build a convolutional neural network which recognizes those signs. And let's see how I can um, build this neural network. Before that, I need to analyze those signs. It is very obvious to me that I have basic shapes, right? And uh, combined shapes. So the basic shapes is this is a horizontal line, vertical line, slope, negative slope, positive slope, okay? Then I have those combined signs because this plus sign combines these two, right? A horizontal and a vertical. The multiply combines these two, right? And the diamond combines these two. And this one here combines, let's just use a different color here, combines this this and the vertical line. And you can see what's the idea here. I'm trying to find the what are the basic features that so this arrow, for example, has we have a positive slope, negative slope, horizontal line, and a vertical line. Okay. Similarly, the yacht has these slopes and lines with negative and positive slopes, and has horizontal line and a vertical line, but not all the way to the end. So you can see that these are my basic shapes and these are my combined shapes. Okay. So that leads me to what? That leads me that I want to design a convolution network with fixed kernels, with fixed filters, fixed values. I'm not going to train them. And then extract these basic features, right? And I detect them. And then once I extract them, I'm going to send the results to a fully connected neural network, which will recognize what is this these features. Okay, so I will extract these features and I'll let the values of these features for the fully connected neural network. So detect the basic features, then detect the composite features, and then fully connected neural network. These are the steps of my design. Okay, let's reiterate. First, I'm going to detect the basic feature, the simple ones: horizontal, vertical, negative slope, positive slope lines. Okay, and then detect composite features. Okay, all right. These features include a horizontal line shifted to the top, a little bit to the top, horizontal line at the bottom of the page, a vertical line not centered, a little bit to the right, and vertical. This should be vertical line. Okay, so the vertical line to the left, and then a negative slope line, a positive slope line. Okay, and then those are negative slope lines, but not all the way to completed. Okay, one is a short line and the other one with a sharp angle. Similarly, those positive slope lines, one short lines, one with a sharp angle and one with 45 degrees. Those are my composite features. Okay, and then I will send these features to the fully connected neural network. Okay, so let's see how my neural network. So in other words, what I will do here basically, I'm going to see these are my composite features. Once I'm done, okay, which means that I have passed through stage one and stage two. Once I'm finished with the stage two, right, I'm gonna identify these features, right? These features in my image. So you see, if I am horizontal line, you will see that if my image is a horizontal line, you will see that these two features have large values. If my image that I am testing right now is a vertical line, you will see that these two features of vertical lines has the large values. Okay, if I my image is a positive slope line, you will see this feature has large value. Okay, okay. And if a negative slope, this feature is large value. If a plus sign, if I have a plus sign, then you will see this feature, this feature, this feature, this feature with large values. Okay, etc., etc. And you can see the Yacht probably is taking all these features because the Yacht got a vertical, got a horizontal, got a negative slope, got a positive slope lines. Okay, so you can see how these images will have a little bit or some of the values of these composite features. Now recall that these composite features I detected them from basic features. Okay, all right. Now, so let's see my convolutional neural network, what it consists of. This is how I will deal, how I will construct my convolutional neural network. I will take my black and white or gray image. I will binarize it. Okay, so we'll have just ones and zeros. Okay, it's gonna be 19 by 19 matrix, and then after binarization, it will be 19 by 19 binary values. Okay, then I'm gonna apply a filter here, or kernel, which is 5 by 5, 5 by 5, right? And since I have one channel here, and I'm gonna end up having four channels, so it means I need a four filters here, or four kernels. But notice the output of this the physical dimensions for this feature map is 8 by 8. Then I'm gonna apply max pooling. Then it will be 4 by 4, 4 by 4. But I have what, a depth or four channels here. Okay. Now I'm done here. Then I'm gonna go to the next layer of filters. Okay, where I will produce 10 channels here. So here 10 channels, and here 4. So therefore, number of channels here is what? 4 times 10, 40 filters. 40 filters. That will produce for me these 10 channels, okay? And then the dimensions of these of this feature map is 2 by 2 from 4 by 4 as an input feature map. Then I'm going to apply max pooling, right? This will make it 1 by 1 times 10, which means like just an individual numbers. And there are 10 of them. And then I will send those to my fully connected layer. And then I will produce the outputs here that represent the images. Every output says that this image is a horizontal line. A second output will say this image is a vertical line, etc. So I'll have 10 images. I have 10 output to classify the image. So this is the overall architecture that what I'm proposing. Let's zoom in to this layer, then to this layer, then the last layer. Okay, so basically, I'm going to convert, if I have a colored image, I'm going to convert it to a black and white image. Then I'm gonna play with the sort of the values of the white and black. At the end, I'm gonna binarize the value such that I'm gonna have the white pixels will have a value of a 0, the black pixel will have a value of a 1. So this is the binarization step that I'm doing right here. Okay, and let's see. Uh, so then 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 what we do here is that we apply these filters. Okay, so we extract the four basic, we wanted to extract the four basic features. And what are these four basic features? Well, if I go to the beginning, I said these are my four basic features: horizontal line, vertical line, negative slope line, and positive slope line. These are my, I want to extract them. So how do I extract them? Okay, well, I apply filters. Okay, so these are the filters that I apply. I take the image, which is 19 by 19 by one channel, okay, which is a depth of 1, and I convolve it with these fixed matrices, with these fixed, sorry, filters or kernels. Watch, to extract the horizontal line, all the values of this filter are zeros except a horizontal one at the middle. And so this will extract for me if there is a horizontal. How about this kernel here? It will detect if I have a vertical line. How about this kernel here? It will detect if I have a line with a negative slope. How about if this kernel here, it will detect if I have a line with a positive slope. Now, all these features, I'm going to apply them, and then I will get 8 by 8, 8 by 8 a feature map, and I will have 4 channels. And those I will apply a max pool on them, and I will get 4 by 4 feature map and 4 channels. Okay, so that is basically this step right here. This step right here. Okay, I covered this step right here of my convolutional neural network. So let's go to layer 1, which is right here now. So now layer now 1, what happens is that I'm going to have notice I stopped at 4 by 4, okay, and I have a depth of 4, and I want to generate a 2 by 2, 2 by 2 with a depth of 10, okay. So I will use a 40 filters. Why 40? Because I have an input, the depth of the input feature map is 4 times the depth of the output feature map is 10, or you can say the input channels are 4 and the output channels are 10, and that results in 40. I need 40 filters. Okay, so this is here. Okay, and so I'm gonna apply the filters, and then I'll get 2 by 2. and then I apply a maximum pooling here, and then I'll get individual values. So let's take a look here and see. So these are the values of these filters. These are the values of these filters. So I'm gonna get these 4 by 4 and apply them on those filters. Okay, those filters relate to the first output channel. Okay, let me use actually a different color here. Mm, okay, so these are relates to the first output, and then I'm gonna have another 4, okay, which will be used to the channel 1, okay, all the way to channel 10. These are the last one, will be used to produce, or let's say 9. This is channel 9, since I start enumerating from 0, so this is channel 9 into the 10th channel. Okay, applying maximum pooling. Notice that if I apply maximum pooling here, I get a 10. Maximum pooling here, I get a 4. So I'm gonna get at the end 10 numbers representing the features that I started with the input image. Okay, so now here are a test cases. These are my images. Okay, these are test images, and I apply them to my input. uh, I did the extraction, and for input image, notice what I have is the extracted value, the 10 extracted value. Okay, so those 10 extracted values represent the composite features. Okay, right? The composite features that I have. Okay, notice that the horizontal image that I have, it has a largest value for the horizontal line, which is in the upper side of the image. Okay, so up here. 0, because my test image, the line was a little bit up here. You can see that the largest feature value, it belongs to the composite feature that detects a line which is shifted a little bit above the center. Okay, now look at the vertical line here. Look at here. It is for the composite feature which detects the vertical line shifted a little bit to the right. Again, you look at the positive slope here. Okay, all right. So what I want to identify, highlight here is that every image will result with the largest feature that identify the feature inside it. So this belongs to the slope. Then the negative slope line. Watch here, right? And then we get here something of mixed things. Look at the plus here. It detected a line, horizontal line. It detected as well a vertical line. I'm looking at the largest values, by the way. I know the other features have some weights, but I'm looking at the largest value because as long as you have largest value, you are enabling the fully connected neural network to recognize these. Okay. How about the multiply? Watch here and here, 10 and 10. For what? For these slopes. Okay. Then we get to the diamond here. Okay, 10 and 10, and the question here, how does the fully connected distinguish this from this? And the answer is that it will, because notice that the rest of the numbers are not identical. Take a look at these here. Okay, they are not identical, so the fully connected network will start distinguishing that which is through training, which is really a multiply and which is a diamond. Okay, all right, now we move on with a 3-point star, the inclined, okay, and the vertical line, because this is the vertical line, these are inclined. So it detected those features, composite features. Also, we have here a little bit of slope, a negative slope composite feature. It is actually common with also, These are being detected also for the multiply sign, diamond sign, and 3-point star. The arrow, we know that we have a horizontal line, which is right here. We know we have a vertical line, which is right here. We know we have an incline here and here. So see these, okay? And we know have a slope here, small slope here, which is right here, okay? And the yacht, something similar, okay? But notice that the yacht, all right. The difference between the arrow and the yacht, okay, is this number here, okay. And the yacht got this slope, okay, which is right here, okay, and right here. That's why it has a large value here. So it detected more of this feature. So that's how the fully connected network should distinguish between the arrow and the yacht. Okay, so hopefully that now these are the values, right? These are the values that are coming from here, and these are the values that will go to the if I go back here, these are the values that will go to the fully connected neural network. And now in your fully connected neural network, as you train them, it will recognize this neural network that these type of numbers or features belongs to horizontal line, belong to yacht, belongs to 3-point star. Okay, I hope with this example that I explained, where we have applied images of 10 signs, and we have gone through 1, 2, and 3 layers. Two of these layers are convolution layers, and we used fixed value pre-computed kernels, okay, and then we send the output features to trainable, fully connected neural network. And with that, I think this conclude my presentation of this example, okay, where we discussed in this lecture part one and part two, the convolution neural network, and two examples for it. And thank you very much for your listening. I'm gonna conclude the presentation and uh, turn off the recording.